All right, this next unit that we are getting into, we're going to call it Unit 2, it's called Geometric Application of Exponents. All right, and we just finished a long unit on exponents and the inverse of exponents, which are called square roots. And we looked at multi-step equations, but now we're looking at geometric applications of exponents. And what that means is we are now going to be applying what we've used with exponents to geometric concepts. Okay, so we're going to be looking at formulas that we use in geometry that have exponents in them. Okay, let's see here. All right, so what we are going to be looking at first is what is known as, we're going to look at some terms here. If you don't understand what the terms are, you're not going to understand what the concept is. All right, we are going to be we're going to be studying what's called the Pythagorean Theorem. It's a big old long word. It's based on the supposed or the thought to be creator, or not creator. Let's first talk about this. Math is not created. We didn't create this. People are all the time like, who made this up? Like, who even did, like, who created this, you know? And it's like, no one created this. It's not like we took some magic wand and we said, oh, we're going to use this theorem or this formula we discovered this, okay? It's like when Columbus discovered the New World, all right? When he came to America, it's not like he created the Americas, all right? He discovered it. It's like he found it. It's the same thing with math, okay? We don't create this stuff. This guy, his name was Pythagoras, and he was Greek, right? And he is credited with coming up with the formula, or coming up with the concept, or discovering the concept of the Pythagorean theorem, what is now called the Pythagorean theorem. But that's garbage, all right? The Pythagorean theorem, what we're going to be using to figure out the missing sides of right triangles, was thousands of years before him. He just put a title to it. He just he put a label on it. Have you ever had like an idea and you came up with it and someone else stole it, or someone else just put a title onto it and they got the credit for it, whereas you're the one who created it, but someone else just put a title on it that made it look good and they got credit for it? So that's exactly what this guy Pythagoras did. It was like 550 BC, which is like, BC was years before year zero. And then, so it's kind of like it's kind of like negative numbers. You go from this direction would be like 5,000, and then 4,000, kind of like with negative numbers. And then you have year zero. This is what we know as BC, and this is what we know as AD, Anno Domini. And so we are now in the year 2018. So in the year 550 BC, which is about right here, this is when Pythagoras was alive, all right? And he was in Greece, about like right here. Well, like 2,000 years before that, like right here, the Egyptians were doing this way before he was even born. Okay, even before that, I think they have found something in the city of Sumer. They found more evidence of the concept, that people were using this concept to figure out the sides of right triangles way before this dude Pythagoras even put a title onto it. So he got credit for it. That's just a little background for it. What the Pythagorean theorem says is we need to first know some terms, and we're just going to look at, this is just like an introduction, right? A right triangle This is a triangle with one right angle. And a right angle is, of course, 90 degrees. And if you remember that every single triangle in the entire universe has the three angles add together to give you 180. Well, if one of them is 90 degrees, you can't have a triangle have two 90-degree angles, because that would already give you 180. You know, it has to have three angles in order, by definition, to be a triangle. So, triangle. So, a right triangle is a triangle. This is not a right triangle. There's not enough information that tells you this is a right triangle. Now it's a right triangle. This little notation right here means that this is a right angle. It's 90 degrees. You can't assume that. We're going to be figuring out what the missing sides of a right triangle are given the two other sides. All right, so we're going to just call this side length right here A, and we're going to call this side length right here B, and this side length right here we're going to call it C. If you're given the lengths of A and B, you can solve for C. And if you're given the lengths of A and C or B and C, you can solve for the other side, okay? And that's what we're going to be doing here. The two shorter sides are what is known as legs. These are the two shorter sides, all right? And they're always A and B, all right? The longest side is what we call the hypotenuse. I don't know why we use these terms, okay? I'm assuming that this word is Greek, all right? Legs is obviously not Greek. Or it might be. I don't know if it has its foundations in Greek or not, but you know, the two shorter sides are what we know as legs. They are always going to come together to form the right angle. And the hypotenuse, there are two ways that you can identify the hypotenuse. Well, three ways actually. It's always going to be the C. It's always the longest side, and this is important, like how to identify the hypotenuse. If you don't do this, you're going to get the whole question wrong. And it's always across from the right angle. It's kind of like the right angle. There we go. It's always like the right angle is going to be pointing at the hypotenuse. Okay, so it doesn't matter. Like it's. Some kids always say it's the slanty line. Well, no, because sometimes you could have a right triangle drawn like this, and you know that's not slanty. This is the hypotenuse. It's across from the right angle. Okay, so it depends on what the triangle is going to be looking like. All right. So we have the hypotenuse, we have the legs, we have right triangle. If there's any more terms I can think of that we need to know, we'll kind of go. We'll define them as we go along, okay? So, you are going to be given a triangle. Now, let me go ahead and take this time. What is the length, or how long, or what is the distance? If you are talking about length in the 8th grade, this is going to be the Pythagorean theorem. This is what we're studying right now. There is no other concept in the 8th grade that we discuss having to do with the length of something that you would do other than the Pythagorean theorem. And the one exception to that might be, what is the side length of this square, which y'all did terrible on for your last test. If you're given the area, you can figure out the side length by taking the square root of the area. So if this is, 64, you take the square root of the area, that gives you the side length of the square. All right, you don't divide by 2 or anything like that, which is what y'all wanted to do. All right, if it says what is the length, or how long is it, or how far is it, what is the distance, that is going to be Pythagorean theorem. There is no other time we're going to be looking at distance in the 8th grade other than when we're using the Pythagorean theorem, or what is the length of side B or something like that. That is always going to be what's called the Pythagorean theorem. And the Pythagorean theorem, this is what it says. Or here, let's do this. The Pythagorean theorem, a theorem is something that we know to be true. I know that theory, we think of a theory as something that's it might be true, like this is what we think. a theorem in math is something that we know to be true, okay? Like, take this square up here. We know that a square has 4 sides that are the same length, okay? That is, I mean, you could, it's not technically a theorem, but it's kind of the same principle, all right? This square, we know by definition, is going to have 4 angles, and it's going to have 4 sides, and all of the angles are going to be the same measure. More importantly, all the sides are going to be the same length. A theorem is something that we know to be true. So the Pythagorean theorem says for any right triangle, the sum of the squares of the 2 shorter sides is equal to the square of the longest side. This is how you would write it in English. How you would write this in math is you'd say you take one side and you square it, and you add it to this other side and you square that, and that is equal to the longest side squared. All right. If you ask your mamas and daddies what the Pythagorean theorem is, I think that if they studied, like they have studied this, all right, they may not remember it, but they have studied this somewhere along the way in math. All right. Now, if they did, it's something that's going to stick with you. All right. A squared plus B squared equals C squared. It's just one of those things that you're going to do so much in the next several years, and you're just expected to know. It's something that's going to stick with you, all right? A squared plus B squared equals C squared. This is the theorem that we're going to use. So we already said that the 2 shorter sides are what we call A and B, and the longest side is going to be C. That's the hypotenuse. If you are given the 2 numbers, you can always solve for the third, okay? Just like if we had an equation like 3 plus x equals 10, you can always solve for what that one variable is. But if you have 2 variables like x plus y, we're not taking this into consideration now, x plus y equals 7, you could have any numbers be right here for x and y. I mean, well, not any, but it's like you could have a 4 and a 3, you could have a 5 and a 2, you could have a 1 and 6. So you can't solve for what those 2 variables are because there's 2 unknowns, all right? But if you're given 2 of the variables, if you're given 2 side lengths, you can always solve for the third. This is what this is going to look like. I'm going to do one example, and then we'll look at the next video of some other examples here. Well, let's do this. You have a right triangle. Looks like this. When you square one of the sides, you are quite literally, a geometric representation of this would be you turning this into a square. So if I took this side length right here, which is represented in red, and I squared that side length, I turn it into a square. And I'm looking at the area of this entire square right here. Okay? Now, if I took the side length here, the other shorter side, and I square it, I'm going to be taking the area of that square. So I've taken the side length here, which is in red, and I square it. Take the side length here in blue, I square it. What that is equal to, it is equal to the area of the longest side squared. So if I were to take all the area of the red square and I put it like right here, like so, this red square, if I put it all right here, and I take this blue and I put it all right here, it's going to completely fill up the green side right here. All right, it's going to completely fill up the longest side squared. Okay, now notice how I did not say you take the red side, you add it to the blue side, and it gives you the green side. It's you take the red side and you square it, and you take the blue side and you square it, and it's equal to the green side, and you square that, like when you square that. Now, how this is going to look, so this is like a proof of what that looks like. You're going to see that again. All right, that is because one of the things we have to do is we have to prove that's true. So what this would look like as a question, and just a most basic Pythagorean theorem question is if we have a right triangle here. It says this is 3, we'll just say centimeters. This is 4 centimeters. How long is this in centimeters? So the very first step you're going to do, step 1, is you write down the formula. And we're going to write down the steps in the next video. Step 1, write down the formula. Step 2, you're going to plug in the numbers starting with the C value. The C value is always the hypotenuse, always the longest side. In this case, the C value is the question mark, so we're solving for C in this question. We're going to put a 3 in for A, we're going to put a 4 in for B, and now we're going to solve for C. So we put a 3, just where that A was, we put the 3 in there. And I've got kids beating down the door trying to get in here right now. I took this 3 and I put it in here for A. Now I'm going to take this 4 and I put it in here for B. And now I'm going to solve for C. So I'm going to now simplify this. 3 squared would give me 9. 4 squared would give me 16. That's going to give me C squared. Now what kids want to do is they want to add those together and put them on the right hand side, and that you're going to get all kinds of confused. You're going to leave those numbers on the left and you're going to say 25 is equal to C squared. Now this side is not 25. This is 3 centimeters. That's 4 centimeters. Can that be 25 centimeters? Like, draw me a picture. Show me how that would work. Does that make sense? Like, that can't be 25. That's 3 and that's 4. That's because the C is not by itself. In order to get the C by itself, it's being squared. You're going to do the opposite of squaring a number, which is not dividing anything by 2. You're going to take the square root of the right-hand side. The square root of C squared, if you can remember, is C. If you take the square root of the right-hand side, you got to take the square root of the left-hand side. The square root of 25 would be 5 or negative 5. And since we're dealing with distance, you're always going to use the positive answer for when you take the square root. So this would give you 5 centimeters. All right. If we were to take the area of this square and add it to the area of this square, you would get 16 and 9, and all of that would equal 5 squared, which would be 25. Okay? We'll look at the next video coming up, and we'll look at some more examples. That's the basics for it right now.